Hey everybody. We're moving on to chapter 1 in our pre-calc trig. So chapter 1 is talking about functions and graphs. And today on 1.1 we're going to talk about graphs. And this really, for the most part, should be a lot of review for you guys. We're going to look at an equation to be able to graph an equation, know how to plot points, look at a table to see if we can find x-intercepts and y-intercepts, and be able to identify information like within a graph. So let's start by looking at our coordinate plane. And we're going to say we're on an xy coordinate plane. So we can go through and we plot our points on these, and we have 4 quadrants, and we label our quadrants. This is our first quadrant, and then going counterclockwise, this is our second quadrant, this is our third quadrant, and last but not least, this one is our fourth quadrant. Right? And then we can go through on quadrants. Ours is just the xy coordinate. Technically you could use any 2 variables, but we like to stick with x's and y's for points. Have x, y, and then we can plot points on here, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And if I wanted to plot the point, let's say 3, 4, how would I do to plot the point 3, 4? Well, my x is 3 and my y is 4. So starting at the origin, I'm going to go over 3, and then I'm going to go up 4. 1, 2, 3, 4. And right there is the point 3, 4. If I wanted to graph the point, let's say negative 2, 3, I start with my x's, so starting at the origin, I'm going to go back 2, and then I'm still going to go up 3 because it's positive. Right? 1, 2, 1, 2, 3. Right about there. So I'm hoping that you guys remember how to plot points and figure out those ordered pair. I didn't give you guys any homework problems on those. I was hoping you guys may still remember how to do those. If not, shoot me an email or we can talk about it in class tomorrow. Another way to look at data points is they can give us a table. So a lot of times we have these x, y tables, but sometimes we like to look at more than one function at a time. So we can actually have multiple functions on one table. So our x values are always going to stay the same because that's like our reference point. But let's say we looked at like 2 or 3 different other equations or functions. Your first function, you would label it as like y, and then that's just a little tiny 1 like below. It's called a sub 1 because it's below. Sub would be below. And then you could have another one, say y2, and let's just say we had another one for y3. Right? And for our x values, let's just say we have negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay. And then we can plug in some values. So in our first function, our value would be negative 1, and our second y value, negative 4, and negative 6. I'm going to pause the video and fill in the rest of these. The rest of the table. Alright, so now that the table is filled in, if you guys want to, now you pause your video if you want to fill this all in onto your notes. So let's talk about all this information that we're seeing up here. So what we're saying is when we put in a value, an input of negative 3 into our function, depending on what function we have, we're going to have 4 different values. If we put negative 3 into our first function, we're going to get negative 1. If we put negative 3 into our second function, we're going to get negative 4. If we put negative 3 into our third function, we're getting negative 6. So granted, you could actually create 3 different tables where, like if I killed all of this off of here, right? So there's your XY table. You could then create another table where you're taking this one and this one out, and you could create a third table where you're taking these out. But that kind of gets cumbersome, and it's easier sometimes if it's all put together, because there's certain things that we're going to start looking for. So one of the things we can look for is y-intercepts. And if we go back up to our graph, so a definition of a y-intercept would be where a point is crossing the y-axis. And when we're looking at our y-axis, because our y's are always going to change from infinity to negative infinity is your y-axis, but we know a special value, and we know this point right here at that origin, the x value is always going to be 0. So no matter where I cross the y-axis, my x value is always going to be 0. So when I'm looking for my y-intercepts, when I'm looking for my y-intercepts, I know that my x is going to equal 0. So now if I go back and look at my table, and I want to sit there, and if I want to find my y-intercepts, so let's say I ask the question, what is the y-intercept for y2? So my question is on this second function, where am I crossing the y-intercept? Well, I know if I'm crossing the y-intercept, my x value has to be 0. So here's where my x value is 0. So I'm looking at this line, and I'm looking for my y2. So my y-intercept is at 2. And I could ask the same question if you know what is the y-intercept for y3? Well, y-intercept, I know my x value is going to be 0. y3 is 0. So hey, I go right through the origin. On top of the x-intercept, we could talk about the x-intercept. Guess we should take, I guess I can leave the s on there. If I go back up to my graphs, and if I'm talking about the x-intercept, I'm talking about where it crosses the x-axis. So my x values go from negative infinity to positive infinity, but at the origin, I know that my y value is always going to be 0. So no matter where I cross the x-axis, my y value has to be 0. So then I know, give myself a little star, then on an x-intercept, my y value has to equal 0. So then we can ask the question, what is the x-intercept for, let's say, y2? So now I'm going to look through my y2s, and I want to see if I have a value where y equals 0. And as I go through and I look at my y2s, do I find any zeros? Yep, I find my 0 right here. So that's telling me I'm crossing the x-axis. Well, where am I crossing the x-axis? I'm crossing the x-axis when x is -1. So I would have -1. And I could ask the same thing, like what is the x-intercept for y3? Same concept. I'm looking for when y equals 0. These are my y values right here. I'm looking for that 0. I found the 0. What is my x value when I have that? 0, right? And we knew we were going through the origin. So that's how you can find x and y intercepts with looking at a table. So you don't necessarily need the equation or the graph in order to find x and y intercepts. You can look at tables as well. Let's throw one more little thing in there. We like to be able to read graphs. So let's say we wanted to doing, we'll just call it read graphs. So we like to sit there and be able to draw silly representations or crazy little situations, and then for you guys to kind of put it into words. So let's say we have a graph. Oop, close. And I'm going to say my x-axis is time, and my y-axis is number of students. My x-axis is always my independent variable, and my y-axis is dependent, because reading this one, my number of students is going to depend on the time. So we're just gonna not get too complicated when we talk about our students in our school. So we're just gonna say, like, on an average day, you know, how kids are at school, and so how do we read this graph? So we're gonna say we started the day like at, you know, midnight, and hopefully we don't have any students in this time frame, because this would be, you know, 1, 2 o'clock in the morning, when hopefully you guys are all at home sleeping and nobody's sleeping at school. And then all of a sudden, right, everybody starts coming to school. So this could be, let's say, 7:20, right? So students start getting here at 7:20, and students continue to get here and continue to arrive, right? And here's first hour. And then we're gonna stay in school, and we're not gonna go through like those that are leaving for GCI or for dual enrollment. We're just gonna say once you're here, right? And then so you're here throughout the school day, and then at 2:30 the bell rings and students start to leave, right? And some students are in sports, so this decline isn't as sharp as maybe when it came to everybody getting here in the morning, but we kind of dwindled off slowly. But eventually we got back down to 0 because our students don't stay the night. So part of when it comes to reading graphs is if I gave you a picture, you could put a story to the picture, and it doesn't have to be too elaborate, but enough detail about it's increasing, it's staying constant, it's decreasing, using those kinds of words. Sound like a plan? Alright, so I hope you guys enjoy the rest of your day. There's an assignment posted online for you, and I'll see you tomorrow. Talk to you later. Bye.